All right, so now an opportunity to do something quite clever. When we do the inverse of x squared, we've just seen it doesn't really truly make sense because x squared is not 1 to 1. And kind of an escape route for this is to take the following. It's to take only kind of the positive part, so restrict the domain. Okay, so this is kind of that side. But we could equally well have taken the other side. Namely, we could have restricted to the negative side like this. Throwing this away. So that preserves the range. It's still all non-negative numbers, but it's now 1 to 1. We've just thrown away the other part. Of course it's 1 to 1 because any horizontal line looks like works, okay? You end up with one crossing or no crossing, so it passes the horizontal line test. So now let's just try to graph this a second, see what happens. So I'm going to draw a graph through this. Draw the line y is equal to x. And what have we got to do? We've got to reflect this across it. So we've got to reflect it across it, so it's going to have to look like the following. So it's going to look like this. It's not so easy to graph, but it looks like this. So that is the reflection. So what is that? So I'm not going to prove this super carefully algebraically, but I think you can kind of guess what it has to be. So what it really is just the square root function, but not the positive piece, it's the negative version of it. So this actually is y is equal to minus the square root of x. So this is kind of cool. If you restrict to minus x to 0, that's still 1 to 1. It's a different function because it's got a different domain. But if you take the inverse, it's not the square root function because that's just the positive pieces. It's actually the negative square roots. So this guy here is the inverse. Inverse to x squared restricted to the negative part of the number line, or the non-positive part of the number line. Really cool.